Hello students, previously lesson 17 form 4 topic 2 we were dealing with the relationship between heat of a solution, lattice energy and hydration energy. So today lesson 18 we are going to do fuels. So what is a fuel? A fuel is a substance that produces useful energy when it undergoes a chemical or nuclear reaction. So fuels can be solid such as coke, coal, charcoal and wood. We have liquid fuels such as petrol and kerosene. We have also gas fuels which include natural gas, biogas and also petroleum gas. Next we go to heating values of fuels. What is heating values of fuel? This is the amount of heat energy given out when a unit mass or a unit volume of a fuel is completely burned in oxygen. So heating value has the units kilojoules per gram. It's obtained by dividing the molar enthalpy of combustion by the formula mass of the fuel. So that means the formula of using or calculating heating values is equal to molar enthalpy of combustion divided by the relative formula mass of the fuel. So example, the first question, we are told the molar enthalpy of combustion of ethanol is negative 1360 kilojoules per mole. Calculate the heating value of ethanol. So we have seen the formula. It is obtained by dividing the molar enthalpy of combustion by the relative formula mass or by the formula mass of the fuel. So in our case, the fuel is ethanol. So what is the RFM of ethanol? That's where we are going to start. So we start RFM of ethanol. Ethanol is written C2H5OH. So the RM of carbon is 12 multiplied by 2 plus 1 for hydrogen times 6 hydrogens. We have 5 hydrogen here plus 1 hydrogen, those are 6 plus 16 for oxygen. So here we are going to get 46 as the relative formula mass. Next, we are supposed to have the formula for heating value. So we said heating value will be equal to molar enthalpy of combustion divided by the relative formula mass of the fuel, which in our case is ethanol. So this will be equal to 1360 divided by 46. So this negative that we have here, it tells us that that reaction is exothermic. So we are not going to put there. So putting that in the calculator, we are going to get 29.6, which when round off, we get 30. So the unit for heating value is kilojoules per gram. So our answer is 30 kilojoules per gram. That's the heating value for that ethanol. Okay. Thereafter, we will go to factors affecting use of fuel. The first factor is heating value. You have to consider the heating value of the fuel. Next, number 2, we are having easy and rate of combustion. Number 3, availability. Number 4, ease of transportation. Number 5, ease of storage. 6, you have to consider its environmental effects. Number 7, we are having cost. So 6 is environmental effect, 7 is cost. So let's take examples. 1, reasons for using wood as a fuel. So 1, we are saying wood is cheap or are cheap. Number 2, they are readily available. 3, burns slowly. They can be easily transported. Lastly, when they burn, they do not produce poisonous products. Those are the factors that you may consider or a reason for using wood as a fuel. So next we go to reason for using methyl drizine for rocket propulsion. 1, it ignites easily. Number 2, it has a high heat of combustion, that's 4,740 kilojoules per mole. Number 3, it burns very rapidly, producing large amounts of gases. which in turn create a huge thrust as they escape. Then next, we go precautions necessary when using fuel. Number one, we are told people should keep off from fuel spilled from tankers. Number two, fuel storage facilities should be located far away from populated areas. And number three, we are told charcoal stores should be operated in well-ventilated rooms to avoid poisoning by carbon dioxide or poisoning by carbon monoxide. Then next, we go to environmental effects of fuel. Number one, we are told fossil fuels such as coal and petroleum contains carbon, nitrogen, and sulfur, which on burning produce poisonous gases such as sulfur peroxide, carbon dioxide, nitrogen peroxide, and also carbon peroxide. And we are saying sulfur peroxide and nitrogen peroxide dissolves in water to produce acid rain. So, next, let's go to effects of acid rain. So number one, we are told acid rain wears limestone, buildings, and statues. Number two, leaches nutrients from plants, plant leaves, leading to their death. Number three, leaches minerals from the soil, leading to poor soil for agricultural activities. Number four, it corrodes iron sheets, iron gates, and other metallic structures, and making the building dull. Then lastly, acidifies lakes, leading to death of plants and animals in the lakes, because some plants and animals that live in lakes, they only tolerate neutral environments, so they cannot tolerate acidic medium. Okay. Lastly, we are going to go to measures taken to reduce pollution. Measures that are being taken to reduce pollution. Number one, designing engines which uses unloaded petrol. Number two, fitting catalytic converters to vehicle exhaust systems. Number three, encouraging other means of transport, such as the use of bicycles and electric trains. Okay. Lastly, we are told electronically controlling quantity of oxygen or air mixed with fuel to ensure more complete combustion. That is the end of our lesson.